Hello future engineers and my dear students, welcome to Mudasar Academy. In the previous video, we discussed a model question paper, that is 1BMATC101 for the first 25 scheme. And as you all know, I am going through critical health conditions, so I thought I would pause there. But due to the continuous messages, the comments and the demands from students to upload the solution for model question paper 1BMATC101, I couldn't resist myself, so I am here. So today I will be solving the complete VTU model paper solution for 1BMATC101 for the first 25 scheme. And I also strongly recommend that you refer the model question paper of the other branches, that is 1BMATE101 and also 1BMATS101, which I recently uploaded. So because see, many modules here are in common. Okay, so when you study these papers together, they form a very good question bank for revision. And also please do follow my Facebook page and Instagram page, where you'll find all the important questions or the most likely questions from all the modules. So together with this model question paper solutions and those important questions, by referring which you can easily score 80 to 100% marks guaranteed. And I also shared my WhatsApp number in an email ID in the description. If possible, please do share your question papers after the exams, as these will help the other students in the future. And also please do share in the comments how your exam went and your experiences. So without wasting time, let's begin the solution to the model question paper 1BMATC101. Module 1, first question, question A. With usual notations, prove that tan phi is equal to r d theta by dr. A most compulsory question from polar curves. And this was my very first video. At that time I was fit and healthy. This video has the most likes and views. The link is given in description below, so please do refer the video. The second one is question number 1b. Find the angle between pair of curves r secant square theta by 2 is equal to 2a and r cos square theta by 2 is equal to 2b. So let's solve this here. So we have the question here. So see, find the angle between the pair of curves r secant square theta by 2 is equal to 2a and r cos square theta by 2 is equal to 2b. So as in the polar curve, the first step is we apply log on both sides. Log bracket r into secant square theta by 2 is equal to log of 2a. Fine. Now next step is we apply the principle. Now log a into b will be log a plus log of secant square theta by 2 is equal to log of 2a. Now again see, log a is to k, as you know, is k log a. Based upon that, as I told, everything should be plain. There should be no powers on multiplication allowed in while doing applied mathematics. Okay, so we have log r plus 2 log secant theta by 2 is equal to log 2a. Okay, done. Now we can easily differentiate this. Why? Because see, log r plus log a raised to k is k log a. So now we can easily differentiate. Differentiate log r with respect to theta is 1 by r dr by d theta plus 2 into, see here, differentiation of log secant theta by 2. So change with first log. Differentiation log x is 1 by x. So differentiation log secant in place of x, there is secant theta by 2. So derivative of log secant theta by 2 is 1 by secant theta by 2 again into differentiation of secant theta by 2 will be differentiation of secant x is secant x into tan x. So secant theta by 2 is equal to secant theta by 2 into tan of theta by 2. Again, it's not plain theta, it's theta by 2. So again, differentiation of theta by 2 is nothing but 1 by 2 is equal to differentiation of log 2a is 0 since it is constant. So here 2 and 2 cancels and also secant cancels. So as you all know, please refer my previous videos also. I mentioned a theory in detail. So 1 by r dr by d theta is cot of phi. So cot of phi plus this will be tan theta by 2 is equal to 0. So cot of phi is equal to minus tan theta by 2. Now how do we write minus tan theta by 2 in terms of cot? Because to find angle phi, both the sides LHS and RHS will be same. So tan theta in terms of cot is written as cot pi by 2 plus theta. So here it is theta by 2. So we write this as cot of pi by 2 plus theta by 2. See, both sides cot cancels. So here phi is equal to pi by 2 plus theta by 2. And since they are asking to find angle between, so I'll take this as a phi 1 is equal to. Okay, so I have my first value phi 1 here. So now let's find the second value phi 2. So the difference between phi 1 and phi 2 will give the angle of intersection or the angle between the curves. So same will apply here. So we have log of r into cosecant square theta by 2 is equal to log 2b. Fine. Now again this is log r plus, see, log a into b, log r into cosecant square theta by 2, log a into b is log a plus log b, log of cosecant square theta by 2 is equal to log 2b. Again log a raised to k is k log a, log r plus 2 log cosecant theta by 2 is equal to log 2b. Now it's all plain, no powers, no multiplication here, so you can differentiate respect to theta, and log r always will be 1 by r dr by d theta plus 2 into, see, differential log x 1 by x, so log cosecant theta by 2 is 1 by cosecant theta by 2. Again the differentiation of cosecant x is minus cosecant x cot x, so cosecant theta by 2 is minus cosecant theta by 2 into cot of theta by 2, okay, correct. Again into, see, it's not plain theta, differentiation of theta by 2 is into 1 by 2, into 1 by 2 is equal to 0. Now here again 2 cancels, so this is cot phi minus cosecant cancels, minus cot of theta by 2 is equal to 0. So that implies cot phi is equal to cot of theta by 2, simple one. So here both phi cancels, so I have one more angle phi 2 is equal to what? Theta by 2. This is one more angle I have here, phi 2 is equal to theta by 2. Therefore the angle of intersection is modulus phi 1 minus phi 2, because the angle is always positive, so angle is phi 1 minus phi 2, that is equal to pi by 2 plus theta by 2 minus theta by 2 cancels, so this is what? Pi by 2. So the angle of intersection phi 1 minus phi 2 is equal to, right here, pi by 2, that is equal to 90 degrees, and that is also nothing but when the angle of intersection is 90 degrees or pi by 2, we say it is what? Orthogonal. That's it. So this is the solution which we obtained for this question. Okay, so angle is orthogonal. Fine. Now question number 1c, find the Padel equation for the curve r raised to n is equal to a raised to n cosine theta. This also is solved here, so solution you can check in the description. Okay, the link is given in the description, please do refer that. This is also very, very important problem. Next one is or, question number 2a, find the radius of curvature of the curve x cube plus y cube is equal to 3axy, that is called volume of Descartes, at a point 3a by 2, 3 by 2. Very, very important question in radius of curvature. This problem also is solved in a detailed way. The link is given in the description below. Please do refer that. Okay, and solve it, compulsory question. Now the next question 2b is, so question 2b is, find a radius of curvature, find radius of curvature of parametric curve, it says x is equal to a into t minus sin t and y is equal to a into 1 minus cos t. Okay, so we'll solve this using an easy way, using the Cartesian method only, because as you know the radius of curvature is given as, for Cartesian curve is given as rho is equal to 1 plus dy by dx the whole square whole raised to 3 by 2 upon d square y by dx square. As from your previous classes, your basics, you know that the parametric curve can also be converted to Cartesian curve. So how? So first find dx by dt. So we have dx by dt is equal to a into 1 minus cos t. Similarly, we have dy by dt is equal to a into, here a into differential t was 1 and sin t is cos t, but here a into derivative of 1 is 0, differential cos t is minus sin t, so minus into minus becomes plus. Okay, therefore we can write dy by dx is equal to dy by dt upon dx by dt, that equals to dy by dt is a sin t upon a into 1 minus cos t, a into a 0, and as you know we are discussing the polar curves. Please refer the previous video for all the formulas. Sin t is written as 2 sin t by 2 into cos of t by 2, and 1 minus cos t is 2 sin square t by 2. 2 cancel, sin cancel, cos by, see we get sin cancels, and you know cos by sin is cot t by 2, cot t by 2. Now we need, see we got dy by dx is cot t by 2. Now we need d square by dx square. So d square y by dx square will be equal to, again differentiation of cot theta is minus cosecant square theta. So cot t by 2 will be minus cosecant square t by 2 into, again 1 by 2 into, see you are differentiating here with respect to what? X. That's why, see d square over dx square will be, see dy by dx is cot t by 2, correct? We are differentiating here with respect to x. Therefore, d square by dx square is minus cosecant square t by 2, okay, into 1 by 2, again into differentiation of t is what? dt by dx. Getting it? Again dt by dx. Don't forget chain rule. So this will be again now minus 1 by 2 cosecant square t by 2. What is dt by dx? Opposite of it. So this will be 1 upon a into, see dx by dt is a into 1 minus cos t, correct? So dt by dx will be 1 upon a into 1 minus cos t. This will be again minus 1 by 2 a, okay, 1 minus cosecant square t by 2, 1 minus cos t is 2 sin square t by 2, am I right? 1 minus cos t is again 2 sin square t by 2, so use that. So this will be now minus 1 by 4a. See 1 by sin square is again cosecant square, basic trigonometry. Cosecant square t by 2 upon 1 by sin square. 1 upon sin square is again cosecant square. So cosecant square t by t into cosecant square t by t becomes cosecant raised to 4 t by 2. Okay, so I have got both now. So now let's put here. Therefore, radius of curvature rho is equal to 1 plus, what is dy by dx? We have cot square t by 2 raised to 3 by 2 whole divided by d square over dx square is minus 1 by 4a cosecant square cosecant raised to 4 by 2. 4 cosecant raised to 4 t by 2. Fine. Now 1 plus cot square is cosecant square. 1 plus tan square is secant square. 1 plus cot square is cosecant square. So if you apply it here, so cosecant square t by 2 raised to 3 by 2 upon minus 1 by 4a cosecant raised to 4 t by 2. Here 2 cancels, that is minus 4a rises up, okay, because 1 by 4a, and here see 4a into 1 by, this will be, see as you see here 2 cancels here, correct? Cos cube by cos raised to 4, cos cube raised to cos raised to 3 t by 2 upon cos raised to 4 t by 2. So 1 cos cancels, what remains done? Cosecant t by 2. But what is cosecant t by 2? 1 by cosecant is sine. 1 by sine is cosecant, 1 by cosecant is sine. Therefore, we can write rho is equal to minus 4a 1 by sine t by 2. That's all. Therefore, the radius of curvature is rho, that is always positive, is equal to 4a sine t by 2. That's the solution. So rho is equal to 4a sine t by 2. That's it. I hope you understood the solution here. Fine. Now the next problem is question number 2c. That is, it says, show that rho varies inversely as r is to n minus 1 for the curve r is to n is equal to a is to n sin n theta. Okay. So let's solve this problem here. Rho is the radius of curvature. Fine. Now we have r is to n is equal to a is to n sin n theta. So what we do first, see there is one simple formula to find the radius of curvature of a polar curve, that is rho is equal to r dr by dp. Here this p is what? The pedal equation. And we have solved so many problems on pedal equation, please do refer that. So let's solve this here now. So first, to solve the pedal equation we do the same method, that is apply log on both sides as we did in the polar curves. So apply log on both sides here. So we have log of r is to n is equal to log a is to n sin n theta, again n log r is equal to, again see, log a is to n into sin theta is log a into b is log a plus log b. It is log a is to n into log sin theta right directly. So log a is to n is n log a, because log a is to k log a, plus log of sin n theta. Now you can differentiate this, so we get n into 1 by r dr by 0 plus, see, derivative of log x is 1 by x, so 1 by sin theta, again sin theta is again cos theta, and that will be say into n, okay, because again sin n theta, right, it is, sorry, I missed here. So this was differential log of sin theta will be 1 by, it is sin n theta, sorry, 1 by sin n theta into, again derivative of sin n theta is cos of n theta, again n theta will be n, so n cancels here. We have cot of phi is equal to cot of n theta. That implies phi is equal to n theta. So this phi is nothing but the angle between the radius vector and tangent. Now the pedal equation is given by p is equal to r sin phi. That is p is equal to, that implies p is equal to r sin n theta, correct. And see, the pedal equation is always a constant, no theta is allowed. So from where do I get the value of sin theta? See, from the problem question here only. See here, see, r is to n is equal to a is to n sin n theta. So this implies what? Sin n theta is equal to r is to n by a is to n. Am I right? Okay. So here, if I, in place of sin n theta, see what I got? See, from the question, r is to n is equal to a is to n sin n theta. See, basic mathematics, sin n theta will be r is to n by a is to n. So this sin n theta I put here. Okay. So what's the value of sin n theta we got here? R is to n by a is to n. So the pedal equation p is equal to r into r is to n by a is to n. That is r is to n plus 1 by a is to n. Done? Fine. Now we will use the simple formula to find the radius of curvature ROC. So first, see, we have p is equal to r is to n by r is to n plus 1 by a is to n. Fine. What we will do, we will find dr by dp. Getting it? We will first find dr by dp. Sorry. Here they are asking dr by dp, right? So we have p is equal to r is to n plus 1 by a is to n. Correct? So what we will simply do, we will find dp by dr here. Okay. So dp by dr means differential of p with respect to r. So 1 by a is to n is constant as it is. Differential r is to n plus 1 is n plus 1. R is to n plus 1 minus 1. 1 cancels. So it is n plus 1 divided by a is to n into r is to n. Fine. Okay. Therefore, that implies rho is equal to r dr by dp. That implies rho is equal to r into, see, dp by dr is this much, n plus 1 r is to n by a is to n. So what you need? dr by dp, inverse, ulta of it. So dr by dp will be a is to n by n plus 1 into r is to n. And clearly we can write rho is equal to, see here, a is to n by n plus 1 as it is constant, and this will be, see, r upon r is to n. So I can write 1 upon r is to n. When r is to 1 goes down, it becomes r is to n minus 1, and that's what they have asked in the question. Where is inversely as r is to n minus 1? This is what we have. So I'll underline this now. Okay, therefore we can write simply, therefore that implies rho where is inversely as 1 by r is to n minus 1. That's the solution. Done. Okay, so I hope you clearly understood it. So rho where is inversely as 1 by r is to n. So now we are done with the question number 2c. So now let's move on to the question number okay, so we are done with module 1 now. So now let's move on to module 2. Module 2, first question 3a is obtain the series of the function y is equal to log 1 plus x up to terms containing x raised to 4. Okay, fine. So let's do it now here. So right here, question 3, it's a. Obtain Maclaurin series of y is equal to log of 1 plus cos x up to x raised to 4. That means you have to differentiate how many times? 4 times. Fine. Okay, containing x raised to 4. So this here. So let's solve this now. So first, what is the Maclaurin series? So the Maclaurin series is given by y of x is equal to y of 0 plus x into y1 of 0 plus x square by 2 factorial y2 of 0 plus x cube by 3 factorial y3 of 0 plus x raised to 4 by 4 factorial y4 of 0 plus so on. Because they are in the question, it is for around 6 to 7 marks. It is only asked Maclaurin series for y is equal to log 1 plus x up to x raised to 4 terms. So difference only 4 times. Okay. So we need to find here y of 0, y1 0, y2 0, y3 0, y4 0, where y1, y2, y3 are differentiations. We have the question as y is equal to log of 1 plus cos x. So first we will find y0. So y of 0 will be log of 1 plus. So what is cos 0? Cos 0 is 1. Fine. So 1 plus 1. So it will be log of 2. Fine. Next is y1. So y1 will be derivative of log of 1 plus cos x. As you know, differentiation of log x is 1 by x. So it will be 1 by 1 plus cos x. Again, differentiation of cos x is minus sin x. Fine. Therefore, we can write this as, or see what we can do is, if you want to make things simpler here, see we can do differentiation, it's how you do it. We can use quotient rule, for further differentiation, or what we can do, you can use take it this side, use product rule and do it. This is one more way. As you are aware of the formulas, trigonometry formulas, we can write sin x as sin x 2 sin x by 2 into cos x by 2, correct? Upon 1 plus cos x as 2 cos square x by 2. Fine, so 2 cancels, cos cancels. So we get y1 equals minus tan x by 2. This makes things simpler here. I'll show you how. Okay. You can choose whichever method you want, but I think this, as you know the formula, sin x is 2 sin x by 2 into cos x by 2, and 1 plus cos x is 2 cos square x by 2. So here cos cancels, sin by 1 cos is tan x by 2. Therefore, you can easily write y1 of 0 is equal to, what is tan 0? 0. This is log 2 and this is 0. Okay. Next, y2 will be differentiation of tan x is secant square x. So tan x by 2 will be minus secant square x by 2. The minus sign is there. Again, differentiation x by 2 is 1 by 2. That is y2 of 0 is equal to, see 1 by 2. Secant 0 is 1 because cos 0 is 1. Secant 0 is 1. So this will be minus 1 by 2. Done. One more thing here. Please refer the previous problem also. I solved problems like log of secant x, in which I mentioned that wherever in higher differentiations, the simplest trick, wherever we have secant square, what is secant square formula? 1 plus tan square. Correct. So do it. It will become very easy for you. I show you how. So we can rewrite this as y2 is equal to minus of 1 by 2 into secant square is 1 plus tan square x by 2. Okay. So when we write like this, we can also rewrite this as minus 1 by 2 into 1 plus. See why I am writing like this? Because secant square x is 1 plus tan square x by 2. See the advantage here is, See here, tan x by 2 is nothing but y1. It makes sense, correct? What is tan x by 2? It's minus y1, so square means it will be y1 square only. So 1 plus y1 square. Are you getting it? y1 is equal to minus tan x by 2. So tan x by 2 is minus y1. Agreed. So put here in place of tan square, tan x by 2 is minus y1, so minus y1 square is plus y1 square. That's all. Therefore I have this. That means y3 is equal to now 1 by 2 outside, differentiation of 1 is 0, and differentiation of, sorry, this is minus 1 by 2, right here, minus 1 by 2. Differentiation of 1 is 0, differentiation of derivative of y1 square is what? Chain rule. y1 square is always 2y1 by 2. What is y1 square? 2y1 into y2. Correct? 2y1 into y2. So 2 cancels. So this is minus y1, y2. Therefore, y3 of 0 will be, see what is y1? 0. So minus 0 into what is y2? 1 by 2. So anything into 0 is 0. That's it. Okay. Lastly, we have to find y4. So y4 will be again differentiate this. So minus I'll take outside. It will be a product rule. So y1 as it is, differentiation y2 is what? y3. Plus y2 as it is, differentiation y1 is what? Again y2. So y4 of 0, the last term is minus bracket. What is y1? 0, leave it, plus what is y2? Is minus 1 by 2. So y2 into y2, minus 1 by 2 into minus 1 by 2, that is 1 by 4. So minus into plus 1 by 4 is 1 by 4. So y4 of 0 equals plus 1 by 4. That's all. No, sorry. Minus 1 by 2 into minus 1 by 2 is plus 1 by 4 into minus is minus. Okay, minus 1 by 4. Therefore, that implies we can write y is equal to log of 1 plus cos x. In the series expansion is written as y of 0 is log 2 plus x into what is y1? It is 0 plus x square by 2 factorial into what is y2? y2 of 0? It is minus 1 by 2 plus x cube by 3 factorial into what is y3? y3 is again 0 plus x raised to 4 by 4 factorial into y4 of 0 is minus 1 by 4. So log of 1 plus cos x is equal to log 2. Here see 2 factorial is 2 minus x square by 4, and lastly minus x raised to 4 by, alright, directly here, see x raised to 4 by minus, okay, 4 factorial is how much? 24. 24 into 4. 24 into 4 is 96. Yeah, right. 96. That's all. That's the answer. That's it. Fine. So the series expansion for log of 1 plus cos x is log 2 minus x square by 2, x square by 4 minus x raised to 4 by 96. That's the solution for this problem here. Fine. Okay. So we have solved the question number 3a. Now let's move on to the solution for question number 3b, that is L'Hopital's rule. So as from the basis of L'Hopital's rule, first we assign k is equal to limit as x tending to a, x raised to x minus a raised to x whole divided by x raised to a minus a raised to a. Okay, the limit is given as a. If you put a here, this will be a raised to, this implies a raised to x minus a raised to x by a raised to a minus a raised to a, that is equal to what? 0 by 0. That means we can apply the L'Hopital's rule here, and according to L'Hopital's rule we need to differentiate the numerator upon denominator separately. Okay, so that implies we have k is equal to limit as again x tends to a. So differentiation of this x is to x. Okay, so how do you do it? So I'll do separately here and then put. Okay, fine. Let's say x is to x, that is power form. So what I'll do, I'll take y is equal to x is to x. Apply log on both sides. Log y is equal to x log x. Now differentiate. Differentiate log y is 1 by y dy by dx, and x into, this is product rule, 1 by x plus log x. That means dy by dx will be y into xx, cancels 1 plus log x. That is differentiation of this I have done separately. X raised to x is what is y? X raised to x into 1 plus log x. So I'll put that value here. It is what we are doing when the value is 0 by 0, we are differentiating the numerator upon denominator separately. So we found the derivative of x raised to x as this much. Okay. So let's put that value here. So we have x raised to x into 1 plus log x minus. And this is a very simple differentiation. Okay. Many of the students they avoid this. Differentiation of a raised to x is a raised to x log a. What is that? Derivative of a raised to x is a raised to x log a upon. Again, see we have this again x raised to a differential will be a x raised to a minus 1 and minus 0. Fine. Differential of x raised to a is a because derivative of x raised to n is n x raised to n minus 1. So derivative of x raised to a is a x raised to a minus 1 minus a is a raised to a is constant 0. Now again when you put a limit as x tends to a, I don't think it will be 0. So k is equal to, we get a value as c in place of x put a raised to a into 1 plus log a minus a raised to a log a whole divided by a into a raised to a minus 1. That will be a raised to a plus a raised to a log a minus a raised to a log a whole divided by, now a into a raised to a minus 1 will be 1 and 1 cancels, a raised to a. So now see this cancels, a raised to a is 1, so the value of k is equal to 1 here. That's it. So the solution for this question is 1. Okay. So let's move to the second question now. Our second one says right here, question number 3. Question number 3b, second one. Second one is now, I write it directly, k is equal to limit as x tending to 0, sine hyperbolic x minus x upon sine x minus x cos x. This is a problem given. So first assign k here, k is equal to sine hyperbolic x minus x upon sin x minus x cos x. So if you apply the limit, because limit is x tends to 0, right? Yeah. Sin hyperbolic 0, 0 only 0, this will be 0 by 0. Because sin 0, 0, this is 0. So according to L'Hopital's rule, we differentiate. So, that is limit as x tending to 0, limit as x tending to 0, differentiate this. So differentiation of sin hyperbolic x is cos hyperbolic x minus 1 upon sin x is cos x, again minus, this will be differentiation of x cos x will be product rule. So I will put a bracket here, x into cos x is minus sin x plus cos x as it is, differentiation x is 1. Okay. Now again if you put the value here, so let's simplify this first. Okay. So we have that implies k is equal to limit as x tending to 0. This will be cos hyperbolic x minus 1 whole divided by cos x plus c, cos x minus plus x sin x minus cos x, correct? When you open the bracket, minus cos x. So here cos x cancels. So again when you put a value here, cos hyperbolic 0 is 1. So this will be 0 by 0. So again we have to apply the L'Hopital's rule. So that implies k is equal to limit as x tending to 0. See, differentiation of cos hyperbolic x is what? Sin hyperbolic x. Okay. See, differentiation of sin x is cos x and cos x is minus sin x. But in hyperbolic function, differentiation of sin hyperbolic x is also cos hyperbolic x, and derivative of cos hyperbolic x is also sin hyperbolic x upon again x as it is, product rule, into cos x plus sin x as it is into 0. Again if you apply the limit here, sin hyperbolic is 0, but again this will be cos 0 is 1, 0 into 0, 1 into 0, 0 plus sin 0, 0. So again let's apply the L'Hopital's rule one more time. So limit as x tends to 0, differentiate the numerator separately upon denominator. As you know, sin hyperbolic is cos hyperbolic x, the derivative of sin hyperbolic x is cos hyperbolic x, and this x as it is, product rule, cos x is again minus sin x plus cos x as it is into derivative of x is 1, again plus this will be sin x is cos x. So that implies now k is equal to, let's apply the limit. I don't think it will 1 now, it will 0 now, because cos hyperbolic 0 is 1 upon, see this is 0, sin 0 0, but cos 0 is 1, cos 0 is 1. Perfect. So 1 plus 1 is 2. So right here, so the final value here is k is equal to 1 by 2. That's all. Interesting problem. Okay. So we have solved problem number question 3b, both 1 and 2. Next C, question 3c. We solved here. So we have question 3c. It says u equals to x cube minus 3xy square plus x plus e raised to x cos y plus 1. Show that dou square u by dou x square plus dou square u by dou y square is equal to 0. A simple question for 7 marks, question number 3c. Okay, so let's solve this now. We have here first, see, dou square u by dou x square plus dou square u by dou y square. We need to find dou u by dou x. So dou u by dou x first, that will be, see, when you are differentiating dou u by dou x, you are partially differentiating only with respect to x, keep in mind. So x is here, it will be 3x square minus 3y square, don't touch it, as it is, differentiation of x is 1, done, plus, again x is there, so it will be 1 only, plus cos y as it is, again, since we are differentiating only with respect to x, differentiate e raised to x, e raised to x, that's all. Okay, so we found dou u by dou x, so let's find for dou square u by dou x square. That means we are differentiating here with respect to, again, what we had done for dou u by dou x, again we need to partially differentiate with respect to what? X. Okay. So again, difference 3x square is 6x sorry, and 3y square there is no x term, so 0, 1, constant 0, and here cos y as it is, differential e raised to x is e raised to x. Done. Now we have found for dou u by dou x. So underline this. Okay. So next one is dou u by dou y. Okay. Dou u by dou y is equal to, here we need to partially differentiate with respect to y. See, minus 3x is as it is, correct. Differentiation of y square with respect to y is 2y, 3 to the 6, minus 6xy, fine. And correct na, 3x as it is, 2y is 2y, 6xy, plus x 0, and again see e raised to x as it is, derivative of cos y is minus sin y, so minus e raised to x into sin y. Again from here dou square u by dou y square, because in the question, it's a very simple question, they need to find only dou square u by dou square and dou square u by dou y square, add it and see if the answer is coming 0. So dou square u by dou y square will be again minus 6x as it is, differential y is 1, minus e raised to x as it is, differential sin y is cos y. Fine. That implies dou square u by dou x square plus dou square u by dou y square equals 6x plus e raised to x cos y. Again, what is dou square by dou y square? So minus 6x minus e raised to x cos y. So damn simple question, everything cancels here. That implies dou square u by dou x square plus dou square u by dou y square is equal to 0. That's the solution. That's it. Okay. Fine. I think the next one is, okay, so we are done with question 3c. So next R, we need to move ahead with now question number 4, ABC. So we have the question number 4a here. Here if you see, z is a function of x and y. Okay, this is a question on chain rule. Okay, function of function. So z is a function of x and y, where x is e raised to u sin v and y is equal to e raised to u cos v. Okay, so that means z, I write here, z is a function of x and y, but x and y is a function of what? U and V. That means Z is a function of U and V, meaning as I explained earlier, Z has two wives, X and Y. X and Y has two children, U and V. That means Z is the father of U and V. So the two kids, Z's two kids will be, one is dou Z by dou U, other will be dou Z by dou V. So we get here the partial derivatives of Z with respect to U and V both. So I think we can put in LHS and check whether the right RHS is satisfied. Okay. So now first, dou Z by dou U will be equal to, see, how do you write it? With respect to X and Y. Okay. So dou Z by dou X into dou X by dou U plus dou Z by dou Y into dou Y by dou U. Similarly, dou Z by dou V will be dou Z by dou X into dou X by dou V plus dou Z by dou Y into dou Y by dou V. That's it. I hope you understood. Now let's evaluate this. See, dou Z by dou X I don't know. Let's keep as it is. Okay. Into dou X by dou U. See, what is X? E raised to U sin V. So here see sin V as it is. Derivative of e raised to U is e raised to U only, because we are partially differentiating dou X with respect to only U. Fine. Then plus dou Z by dou Y as it is, dou Y by dou U will be, see, Y is e raised to U cos V. So here also see cos V is as it is, okay, is into, that's why cos V as it is, differential e raised to U is e raised to U. That's it. Now similarly, dou Z by dou X as it is, see, differentiation of dou X by dou V. Here see, we are differentiating with respect to V. So e raised to U as it is, differential sin V is cos V. Fine. Plus again dou Z by dou Y as it is. Then dou Y by dou V will be again e raised to U as it is, differentiation of cos V is again minus sin V. Okay, done. Now what we'll do, we'll in the LHS, what is LHS? LHS left hand side is equal to dou Z by dou U square plus dou Z by dou V square, and that is equal to, what is dou Z by dou U? So it is e raised to U sin V dou Z by dou X square. I have completed it. Okay. So it is e raised to U sin V dou Z by dou X plus e raised to U cos V dou Z by dou Y square plus dou Z by dou V will be e raised to U cos V dou Z by dou X minus e raised to U sin V dou Z by dou Y square. So let's square this. So we have this as, see, a plus b the whole square is a square plus b square plus 2ab. So this will be, if a square, this will become e raised to U square is e raised to 2u sin square V dou Z by dou X the whole square plus again e raised to 2u cos square V dou Z by dou Y the whole square plus 2ab. So 2ab is 2 e raised to 2 into e raised to e raised to is 2 raised to e raised to 2u sin V cos V, and dou Z by dou X into dou Z by dou Y. Okay. Again plus here, again see here e raised to U cos V dou Z by dou X plus e minus e raised to U sin V dou Z by the whole square. So again a minus b the whole square is a square e raised to 2u square into cos square V dou Z by dou X square. Again a minus b the whole square is a square plus b square, right? Okay, e raised to 2u dou Z by dou Y square minus 2ab minus 2 e raised to 2u sin V cos V dou Z by dou X into dou Z by dou Y. So now here see this cancels. Okay. So what remains here is nothing but, see, I can take here what I can take, okay, I can take e raised to, okay, I can take e raised to 2u dou Z by dou X whole square common, and inside is sin square V plus cos square V. Fine. Again from here Okay, here I can take e raised to 2u dou z by dou y whole square, and common is again here also, yeah, cos square v plus sin square v. And as you know, sin square plus cos square or cos square plus sin square is 1. So this becomes 1. That implies, therefore, that implies we have it here. So dou z by dou z by dou u. So it implies right here. Okay, dou z by dou u. So dou z by dou u square plus dou z by dou v square is equal to, so what you can do is here, as it is 1, so this will be now e raised to 2 is common, e raised to 2u common, because this becomes 1. So here sin square v plus cos square v becomes 1, and this also becomes 1. So what remains, e raised to 2u dou z by dou square plus e raised to 2u dou z by dou whole square. So I can take e raised to 2u common, so dou z by dou x square plus dou z by dou y square. That's it. That's the final solution. I hope it's clear now. So we have here both LHS is equal to RHS. That's all. Okay. That's not how it is solved. So it needs practice. So please practice so that it become perfect. So the next problem is question number 4b. A very, very important problem. U is equal to yz by x, comma v is equal to xz by y, comma v is equal to w is equal to xy by z. Show that dou u v w by dou xy z is equal to 4. A very important problem on Jacobians. I have solved this already. So please refer it. The link you can find in the description below. It's a very, very important problem. Don't miss it. Okay. Also, you can refer the 1BMATC101 model question paper. There also there's one question. Similar question, so please try that also. And question number 4c is, find the extreme value of the function f of x y equal to x cube plus y cube minus 3x minus 12y plus 20. Again, a very important question of maximum, minimum, extreme values. This problem also has solved in a very simple, detailed way. You can find the solution is here. You can find the link in the description below. Please do refer that. Okay. So let's move ahead with now module 3. Now module 3 question 5 is. So we have your question 5a. This question is, solve the differential equation cos x dy equals y into sin x minus y dx. So this is a problem here. So module 3 is ordinary differential equation. So as for the VTU syllabus, we have exact, reducible to exact, linear and Bernoulli's. So let's see what type is this. So let's arrange it in dy/dx form and check out. So we have the problem here. It says cos x into dy equals y into sin x minus y dx. Fine. It means cos x dy by dx is equal to, I'll take this dx down, I'll open the bracket here, y sin x minus y square. Now that implies dy by dx will be, so divide the whole equation by cos x. So we have y tan x minus y square by cos x. Perfect, right? So what I'll do, I'll try to take it this side, that is dy by dx minus y tan x equals 2 minus y square secant x, because as you know 1 by cos is secant. Now clearly this is Bernoulli's differential equation. Okay, because there is a factor y square here. This is a factor y square. So this is what Bernoulli's differential equation. Okay. So now the Bernoulli's differential equation, what is the solution? We remove this y square here. That means we divide by y square, and we y divided by y square, by some substitution we make it linear, and then solve a linear solution. Okay. Okay, so first to remove the y square, divide by y square here. So we get 1 by y square dy by dx minus 1 by y tan x equals, so as you know y square cancels here, this will be minus secant x. Fine. Now we need to make it linear. So as we already discussed before in some problems, this term 1 by y square, this is differentiation of this, the coefficient of dy by dx is always differentiation of this term. Okay, that means when I differentiate 1 by y, I get minus 1 by y square. So what we do here, I will make it linear in terms of some other variable set t. So for that what I will do, I will put 1 by y equals t. So that will imply, so differentiation of 1 by y is what? Minus 1 by y square dy by dx equals dt by dx, right? But I need here 1 by y square dy by dx. That means again 1 by y square dy by dx will be minus dt by dx. Now I will substitute everything here. See, in place of this 1 by y square, I will put this dt by dx. Fine. Now see, 1 by y square dy by dx is what? Minus dt by dx. Write it, minus dt by dx, and here 1 by y is t, minus t into tan x equals minus secant x. Fine. I will multiply whole equation by t and see what forms it becomes. So dt by dx plus tan x into t equals secant x. Now you see clearly it's linear in t. Okay, where p is here tan x and q is secant x. Fine. So we had discussed in the, so you can refer my videos on the playlist. I solve more problems like this. So in that I discussed the linear in y equation. So when the linear in y equation is dy by dx plus py is equal to q. Okay, dy by dx plus py is equal to q, and the solution is y into e raised to integration p dx is equal to whole integration q into e raised to integration p dx of dx plus c. Here in place of y it's linear in t. So the solution here will be here. The solution here will be it is t into e raised to integration of what is p tan x dx is equal to whole q into e raised to integration of tan x dx of dx plus c. That's the solution. Okay, so what I'll simply do, I will find the integration of e raised to tan x and put it here and see what the actual solution is. Now see, we have this. Okay, it's what? Okay, it's e raised to integration of tan x. Dx is nothing but e raised to, what's the integration of tan x? You need to memorize this. Integration is a very standard integration. Integration of tan x is log secant x. Fine. So log of secant x. And again, I discussed this also, very important property. E raised to log of something is something. Say e raised to log x is x. E raised to log x square is x square. So e raised to log secant x will be secant x. That's it. This is what? Secant x. Fine. Now, this value of secant x what I get, I'll put here. Fine. Therefore, the solution is, I write here, solution implies t into, what's e raised to tan x? It's secant x is equal to whole, q is secant x here, into again secant x dx plus c. C is a constant of integration. That means what's t here? T we have chosen as 1 by y. So 1 by y into secant x equals integration of secant square x dx plus c, and a very simple integration. See, differentiation of tan x is secant square x. So obviously integration of secant square x is root of tan x. So it is tan x plus c. Fine. So this is solution. So the solution is, it implies 1 by y secant x is equal to tan x plus c is the solution for this question. That's all. Okay, or you can write secant x by y is equal to tan x plus c. That's the solution what we have here. Fine. Okay, that's the question. Fine. So this is my solution. Fine. That's it. So you can keep it as it is. Okay, so the solution for question number 5 is secant x by y is equal to tan x plus c. That's all. The next one is it's question 5b. The question 5b is, I try to do it here. So question 5 is solve the differential equation x minus y into dx equals dx minus dy equals 0, and the condition is y of 0 is equal to 2 is given. Okay. So condition will see later. First see what type of differential equation is this. If you see this differential equation, I will take that side. That implies x minus y dx is equal to dy. So if I take dx constant, that implies dy by dx will be x minus y. Am I right? Correct. That again implies dy by dx plus y is equal to x. Such a simple question. It's linear in y. It's what? Linear in y. See here. Y. So very simple question. So it's what? Linear in y. Right here. Linear in y. So here if it's linear in y, then clearly see dy by dx, neatly here, dy by dx. Okay. So y and y term is linear in y. So once it is linear in y, see what's p here? P is 1 and q is x. Fine. So as we already discussed in a previous question, when it is linear in y, the solution will be, the solution is here y into e raised to integration of p dx. What is p? 1 dx is equal to whole q is x into e raised to integration of 1 dx of dx plus c. Okay. So this will be y into e raised to, see, integration of 1 is x. That's it. So integration of 1 dx is x is equal to whole x into e raised to x dx plus c. Now that will be, now see, integration of x into e raised to x. I can solve this using integration by parts. Okay. So what's the formula for integration parts? I'll write here. Integration of first into second function is first as it is, integrate second, minus differentiate first, double integrate second, plus double differentiate first, triple integrate second, so on, or the Bernoulli's theorem. Okay, that will be very easy for you. Fine. So here I can write this as x as it is, see, integration of e raised to x is e raised to x only. Fine. Minus differentiation of x is 1. Again integration of the second term e raised to x is e raised to x, because see the first into second function is first as it is, integrate second, integration of e raised to x as it is, minus differentiation of x is 1, again double integration of this factor is e raised to x. That's simple. Make it simple as possible. Okay. So the solution here is, therefore the solution is y e raised to x equals x e raised to x minus e raised to x plus c. This is what we have here. Okay. But now this is a solution for the differential equation. But see, the condition here given is what? The condition is y of 0 is equal to 2. The meaning of y of 0 is equal to 2 is, I'll write here the condition. Y of 0 is equal to 2 is the condition here. Okay. The meaning of this condition is nothing but at x is equal to 0, y is 2. So at x is equal to 0, y is equal to 2. That means in this equation, what you do, in place of x put 0 and y is equal to 2. Okay. So if you do that, what do you get? E raised to 0 is 1. See, that implies, I'll do it here. That implies, put here y is 2 and x is 0 is 0, 1 is equal to 0 minus 1 plus c. Okay. Therefore, c will be equal to, take that side, minus 1 or minus 1 comes this side, 2 plus 1 becomes 3. So the value of c is how much? 3. That's it. So I got a value of c here, that is 3. Okay. So now you understood the condition here is given. Okay, here the condition is here. The condition is given here only to find a constant. So here I found a constant as c. Therefore, the solution now, the actual solution is y e raised to x is equal to x e raised to x minus e raised to x plus 3. That's the final answer. Okay, that's it. I hope you got it clear. So now let's move on to the module 3 question number 5C. Okay, see, the question number 5C is solve the differential equation. Equation is it's given as 3x square y raised to 4, 3x square y raised to 4 plus 2xy dx plus 2x cube y cube. It's x cube y cube, sorry, x cube y cube minus x square into dy, minus x square into dy equals 0. Verify the question carefully. 3x square y raised to 4 plus 2xy dx plus 2x cube y cube minus x square into dy. Okay, let's solve this problem. So now see, okay, this looks like exact. Fine. What is exact? M dx plus n dy is equal to 0. But let's check it's exact or not. So here if you see, m is equal to 3x square y raised to 4 plus 2xy and n is equal to 2x cube y cube minus x square. So the condition of exact is dou m by dou y should be equal to dou n by dou x. So if you find dou m by dou y is equal to dou n by dou x. Okay. Dou m by dou y is equal to dou n by dou x. So here dou m by dou y will be differentiation with respect to y. Be careful here. So only 3x square as it is. Derivative of 3x square y raised to 4 plus 2xy with y will be 3x square as it is. Differentiation y raised to 4 is 4y cube. So 4 3s are 12x square y cube. Okay. Plus 2x as it is. Differentiation y is 1 is equal to dou n by dou x will be partially differentiate n only with respect to x. So differentiate x cube will be 3x square. It is 6x square y cube minus 2x. Fine. Done. See, they are not equal. Not equal. Both are not equal, so not exact. So it can be reducible to exact. So for reducible to exact, what to do? According to VTU syllabus, the method is what? You find the difference dou m by dou y minus dou n by dou x. So we find dou m by dou y minus dou n by dou x will be equal to 12x square y cube plus 2x minus 6x square y cube minus plus 2x. That will be 12 minus 6 x square y cube plus 4x. Fine. What I can do is I can take here x outside. So now this is close to what? It should be either close to m or n. Okay. Now how can you find out that? See, if you see the so n there is minus sign. Okay, it's not close to n. It can be close to m. Just let's check it. So in m, let's check it out. If I take, say, y is common, right? If I take y outside, it will be 3x square y cube plus 2x. Fine. So here also see, I can write this as, I can take 2 outside common and inside will be, I can take 2 common and inside is 3x square y cube plus 2x. Okay, see, both are same. 3x square y cube plus 2x. This is what? Close to m. This is what? Close to m. And when it is close to m, what we do? We find 1 by m dou m by dou y minus dou n by dou x. And that will be equal to, what is m here? I take like this, 1 by y into 3x square y cube plus 2x into, what's the difference? 2 into 3x square y cube plus 2x. See that these terms cancel here. Okay. And this whatever you get is taken as g of y. Okay, if it was close to n, then f of x. If it is close to m, it's taken g of phi. That means here the integrating factor if will be equal to e raised to integration of minus g of phi dy. That will be e raised to minus, what's g of phi? See, if it is close to n, we take the if, that is integrating factor, as e raised to plane f of x dx. But here, since it is close to m, the if, that is integrating factor, is taken as e raised to minus integration of g of phi dy. So minus, what's g of phi? It's nothing but 2 of phi. It's okay, I'll write here 2 by y. 2 by y. So 2 by y, and therefore it implies integrating factor is equal to now e raised to minus 2 by y dy. So e raised to minus 2 into what is integration 1 by y? Log y. Again I can rewrite this as e raised to log of c. Log of a raised to k is k log a. Correct. So k log a is what? Log a raised to k. So minus 2 log m is log y raised to minus 2. And as I told you, e raised to log of something is something. So e raised to log of y raised to minus 2 is y raised to minus 2 only. Or what is y raised to minus 2? 1 by y square. So my integrating factor is what? I have here 1 by y square. So as we discussed in the previous problems also on this, those problems are also very, very important, which I discussed in the videos. Please refer the link the playlist and the courses. Very, very important questions. They can ask this or those questions. Okay, and also please also don't forget to check out the questions or follow my Instagram page or Facebook page. I have given more important questions there also that are equally important for examinations. Now here if is 1 by y square. So what is if? If is a factor which when multiplied with a question which is not exact makes it exact. Getting it? Okay, so what is solution of exact? The solution of exact is integration of m dx plus integration of n only y term dy is equal to c. Now let's multiply this 1 by y square with a question. I'll do directly here. So I'll multiply this. What is if? Once again, if means integrating factor, a factor which when multiplied with a question, the question is here in front of you, makes it exact. So again, no need to check exact. Okay, so multiply the whole question by y square. So that means that implies the question is now 3x square y square, because y raised to 4 by y square is y square plus 2x by y dx plus, correct, 2xy by y square is 2x by y, again plus y square means it is 2x cube into y upon y square minus x square by y square dy is equal to 0. Therefore, the solution now is integration of 3x square y square plus 2x by y dx plus 0 dy is equal to c. Why 0 dy? Because terms, the solution is integration of, the solution for exact differential equation is integration of m dx plus n only containing y terms or constants, no x term allowed. See, in this there are x terms, so it is 0, we don't take anything. Okay, so integration only m dx, that will be now 3 into so what is integration x square? It's x cube by 3 into y square plus 2 into, again integration x is x square by 2, y as it is equal to c. So that implies solution for this differential equation is nothing but, what's that? We have 3 cancels, x cube y square plus 2 cancels, x square by y is equal to c is the solution. That's it. Okay, important problem, but needs thorough understanding of the theory and practice. Fine. So that's for question number 5c. Now let's move on to the question number 5c over question number 6a, or in the or section. Question number 6a. So question number 6a is, it says right here, question number 6a. Okay, it says find the orthogonal trajectories, I write in short form OT, of x square by a square plus y square by b square plus lambda is equal to 1. This is the question, and here given lambda is parameter. That means you have to eliminate lambda. Correct? So as the theory of the orthogonal trajectory for Cartesian curve, we first differentiate to eliminate lambda and then replace dy by dx by minus dx by dy. So let's see how can I solve this question now. So we have the problem here. So let's take it as say x square by a square plus y square by b square plus lambda is equal to 1. So I'll take this as one side. Okay. Now let's differentiate this. So first thing is to differentiate to remove lambda if possible. 2x by a square plus differentiation of y square is I write 2y into y1 by b square plus lambda is equal to 0. Here y1 I take it as dy by dx. Simple. Fine. That implies here now that implies x by a square. So what's that? X by a square plus y into y1 by b square plus lambda is equal to 0. This is what we have. Fine. Okay, the lambda is not eliminated here. So what I do? Now what I do, I rewrite this as say x by a square is equal to, I take that side, minus y1 by b square plus lambda. I'll take this as say 2. Okay. And again, okay, what I'll do is the question, the given question here to find a solution. So from the question that is 1, from the question what I can write, see, I can write x square, see this, x square by a square minus 1, correct no? X square by a square, take 1 this side minus 1 equals minus y square by b square plus lambda. Fine. This is what I have here, x square. Or that again implies, take the LCM here, x square minus a square by a square is equal to minus y square by b square plus lambda. I take this as say number 3. So see, I did this, okay, I took the help of the question. Why I did this? Because if I divide this 2 by 3, so 2 divided by 3 implies, if you divide it, so what do I get? See, x by a square whole divided by x square minus a square by a square equals minus y1 by b square plus lambda. What is that? Minus y1 by b square plus lambda whole divided by minus y square by b square plus lambda. So here if you see clearly, a square cancels, and here I think y and y also cancels, and b square plus lambda also cancels. So that implies now, see this cancels, what I get? X by x square minus a square equals to, minus minus also cancels, y1 by y. This is what I get. Am I right? So y also cancels, right? Yeah. Okay. Now the theory of orthogonal trajectories for Cartesian curves says that replace, or I can write this as I write it. 1 by y, I'll take y1 as now dy by dx. It will be easy to solve. Okay. The theory of the Cartesian curve, that is finding the OT for Cartesian curve, says replace dy by dx by minus dx by dy. Very important condition. So let's replace it here. So it implies we have x by x square minus a square equals 1 by y into minus dx by dy. This is what I have here. Now we need to solve this or integrate this. The solution is we need to separate the variables, x one side and y one side. So if you do that, see, it becomes, if you take this side, see y dy, take this side. So this will lead to y dy, okay, equals to minus I'll take this side. See, when minus go this down, it becomes minus x square minus a square by x into dx. This is what I get now. So let's integrate this now. So the solution will be integration of y dy plus integration of x square minus a square by x dx is equal to c. That again implies right here. So let's separate this. Integration of y dy plus, see here, x square minus a square by x, like a plus b by c is a by c plus b by c. It will be x square by x will be x only. This will be x dx. And here minus a square by x minus a square by x dx is equal to, I'll take c. Okay. I think simple integration. So integration of y dy is y square by 2 plus x square by 2. So what is integration x? Integration x will be x square by 2. Fine. And a square as it is minus a square. What is integration of 1 by x? Integration of 1 by x is log x. Log x is equal to c. So that's the solution. Again, I can rewrite the solution as c. 2 is common here. I'll take the solution, and that implies solution is x square plus y square minus, take the LCM, 2a square log x, 2a square log x equals to 2c. See, 2c, c, k, what is constant only. So I take it as simply c. That's all. So that's the solution. This problem is very, very important, as this has been asked many times in the VTU papers of previous semester also. So, but it needs a lot of practice to understand the question. But I request you to practice 3 to 4 times. This question may be asked in the examination. Okay. So we are done with the question 6a. Next question 6 and b will follow the solutions here. Okay. Here it says a bacterial growth population B is known to have a rate growth proportional to B itself. Okay. If between noon and 2 p.m. the population triples, then at what time no control has been exerted, should B become 100 times what it was at noon? Fine. So this is the growth model question. So right, growth model. So the model is given as Bt is equal to B naught e raised to kt. Fine. Here B at time t, that is B is called a population time t, is given by B naught. That is the initial population. That is a t is equal to 0. T is the time, and k is a constant. So that here in the problem you see, they say if between noon and 2 p.m. the population triples, that means at time t is equal to 2 p.m. the population triples, that is this Bt will be 3 times B naught. Initial population, how much? Initial population is B naught. So now Bt will become 3 times B naught. Okay, so let's put in the formula here. We put in the formula 3 B naught is equal to, we have B naught e raised to 2 into k, where time t 2 is the time, okay, at noon, 2 p.m. Now see, B naught cancels. We have 3 is equal to e raised to 2k. Now apply log on both sides. So ln of natural logarithm, ln 3 is equal to ln e raised to 2k. That is ln 3 is equal to 2k ln of theta. But ln is 1. Therefore, we have ln 3 is equal to 2k. So k is equal to ln 3 by 2. So if you use the calculator here, we get a value of k is equal to, it's natural logarithm. So in the calculator, you have to press the ln button. Okay. Ln of 3 divided by 2 is equal to 0.5493. So k is 0.5493. So you find k here. Now, next is, see, we need to find a time when the population B becomes 100 times. So we are looking for 100x growth. Now that means now initial Bt will become now 100 times. That is initial is B naught. So 100 times B naught will be 100 B naught is equal to B naught. Again B naught cancels here. So 100 is equal to e to kt. So I will apply log on both sides, natural logarithm. So ln of 100 is equal to ln of e raised to kt. So that is e raised kt ln e. This will be kt ln e. This will be k into t into ln of e, where ln is 1, log to natural basis 1 only. So ln 100 is equal to kt. So we get time t is equal to ln 100 divided by k, that is ln of 100 divided by k. K is found to be 0.5493. 0.5493. So that means we get the time T is equal to ln of 100. We will calculate it divided by 0.5493 is 8.384. So 8.384 is the time here. Okay. So this is how we solve it. That's it. Question number 6C. It says radium decomposes at a rate proportional to the quantity of radium present. Suppose that it is found that in 25 years approximately 1.1% of certain quantity of radium is decomposed. Determine approximately how long will it take for half of the original amount of the radium to decompose. This is a problem on half-life. Okay, and if you take, let N be radium at time t. So we have the general formula here. The general relation is N is equal to N naught e raised to minus kT, where N is the radium at time t, T is the time, and N naught is the initial quantity of radium. Okay, so using this formula, let's solve the problem. Now it's given that in 25 years, see, it means time t is equal to 25 years, 1.1% of radium is decomposed. That means from 100% of radium, 1.1% decompose. So remaining is what? 98.9%. It is equal to 0.989 divided by 100. Fine. So now the quantity remaining at present is 0.989 of N naught. N naught is the initial value. So here put in the equation, in place of N put 0.989 N naught. So N naught cancels. So let's find the value of K here. We get this much. So we need to apply ln on both sides. So ln of e raised to minus 25k is equal to ln of 0.989, right? Now the formula log e raised to k log a, and this will be minus 25k ln of e is equal to ln of 0.989, and ln is 1. So we can write k as, so 25 minus 25k equals ln of 0.989. So k can be easily found as k is equal to ln of 0.989 divided by minus 25. So if you use the calculator to find it, so we can write as, see, in the calculator you have to use the natural logarithm ln. Okay, so k is equal to ln of 0.989 divided by it's minus 25. We get 4.24. So we get here k is equal to 4.243 into 10 to the power minus 4. This is the value of k, which you find. Underline. Okay. Now once you find k, we have to find a time t when half of the original, that is half-life. So half-life means initially it is n is n naught. So half-life means again the n naught becomes half. So n naught by 2. So again put in the formula and place again put n naught by 2. So again here n naught cancels. So we get 1 by 2 reduced minus kt. Again apply ln on both sides. So ln of 1 by 2 is equal to ln of e raised to minus kt. That is ln of 1 minus ln of 2 is equal to ln e raised to minus kt is nothing but minus kt into ln of e. So ln of e is 1. Okay, natural logarithm. Again we have ln 1 minus ln of 2. Ln 1 is 0. So 0 minus ln of 2 is equal to minus kt. Correct. So here minus minus cancels. So we have the time t is equal to ln of 2 divided by k. And as you know, you can find it. So ln of 2 divided by k is 4.243 into 10 to the power minus 4. So let's put in the calculator and evaluate. The time is ln of 2 divided by 4.243 into 10 to the power minus 4 is equal to, we get 1566.65. This is the final answer. It is years. That's all. So the question determine approximately how long will it take for the half of the original amount to radium decompose. So it takes 1566.65 years to decompose. That's the final solution. This is how it is done. Okay. So we are done with the module 3. Now let's move on to module 4, that is higher order differential equation, a very interesting and scoring module. Apart from these problems which I am solving, please do refer the playlist and the courses for more problems, and also follow my Instagram page where I have uploaded the most important questions in the examination if you want to score good marks. Now module 4 7a, question 7a, it says solve y triple dash minus 3y double dash minus y dash plus 3y equals 0. Very simple question, but they ask for 6 marks. Okay, so this question can be easily done in 1 minute. Okay, 60 seconds by using calculator, but they have asked the question here for 6 marks, so you need to write the steps. So first, what? Y triple dash means d cube minus 3d square minus d plus 3 into y is equal to 0. See, right side is 0, so solution is only the complementary factor. Now here, now this is written as to find the roots. We write the auxiliary equation as m cube minus 3m square. In place of d, write m minus m plus 2 is equal to 0. So once we are able to find a m, see, m cube means there are 3 roots. Okay, so we can easily find a complementary factor. Because the right side is 0, solution is cf plus pi. Solution is only the cf. A very simple question. I can solve this using calculator in only matter of time, just seconds. But they asked this question for 6 marks, so you have to show everything step by step. So I need to find a value of m first to follow up with that what is called synthetic division method. That is, you can put m is equal to 0, 1, 2, 3 and check. But the best thing is you can use a calculator here. See, I have with me the calculator. I am using FX991 US plus. The process is simple and same for all the calculators. We go to the equation mode, and since it is a cubic polynomial, we select number 4 here. So write the coefficients. It is m cube minus 3m square minus m plus 3, right? Okay, plus 3. Fine. Now 1 equals to m square is minus 3 equals to minus 1 equals to 3 is equal to. See, we get the roots as minus 1, 3 and 1. See, minus 1, 3 and 1. So I can select the lowest root. Either I will select minus 1 or 1. So I will select better minus 1, the first root. Okay, see, I am getting the roots as x1 is minus 1, x2 is 3 and 1. So I will better select m is equal to minus 1. Fine. So one root is m is equal to minus 1 is a root. Now I will do this using the synthetic division method. How? See, simple. Coefficient of d cube is 1 minus 3 minus 1 3. Okay. Now this you have to divide by this. What is that? Minus 1. That is the key. So minus 1. So how? Very simple. Below this 1, put 0. Now 1 plus 0 is 1. See, now multiply. Minus 1 into 1 is minus 1. Fine. Add. Always add them. Minus 3 minus 1 is minus 4. Then minus 1 into minus 4 is plus 4. 4 minus 1 is 3. Minus 1 into 3 is minus 3, and this cancels to become 0. So we see m cube. 1b divided by 1 root m. What remains? M square. M cube means m square. So what remains here? M square minus 4m plus 3 equals to 0. Fine. Now you can again, because see the question they are asking, this is a very simple question for 6 marks. That means you have to show some steps. Okay. Now as I told you, in the calculator we found the roots as minus 1. It was minus 1, 3 and 1. Okay, I will select one more root as m. So m is equal to 1 is also root. M is equal to 1 is a root. Fine. Or you can factorize it also. Yeah, wish. I will do it like this. Okay, for the steps. So again, this will be 1 minus 4, 3 divided by 1. So 1 plus 0 is 1. 1 1 the 1. This is minus 3, 0. Okay, so last remaining is m minus 3 equals to 0. That means m is equal to what? 3. That's all, is a root. Therefore, we have 3 roots here. Since m cube, the roots are m is equal to minus 1, 1 and 3. That's all. Underline it. Okay. So we have the roots, all different real and distinct roots Therefore, the solution is nothing but we have solution is y is equal to CF, because the right side is 0. So y is equal to, so for minus 1, 1 and 3 are different roots, C1 e raised to minus x plus C2 e raised to x plus C3 e raised to 3x. That's the answer. That's all. So you can show all the steps for getting the complete 6 marks. Okay. If you write directly using calculator roots and solution, you will get 1 marks. That's it. Now the second one is 7b. Question 7th B. It is d square minus d plus 1 into y equals sine hyperbolic x. Okay. So let's solve this question. Again we have m square minus m plus 1 is equal to 0. So we'll use the calculator to find the roots here. M square means 2 roots again. So mode equation of 2 root set, it is square. Okay. Number 3. So 1 equals to minus 1 equals to 1 equals to. We get the root as m is equal to 1 by 2 plus and minus. Okay. Plus or minus root 3 by 2i. Fine. So we get this as the root. What is that? 1 by 2 plus or minus root 3 by 2i. Therefore, the CF will be, see this is the conjugate imaginary root. Okay. So like for if I am getting from the theory m is equal to a plus or minus bi, you can write the CF as c1 cos bx plus c2 sin bx into e raised to x. Here also CF will be c1 cos of root 3 by 2x plus c2 sine of root 3 by 2x whole into e raised to 1 by 2x. This is the CF. Please underline it because this is going to fetch you marks. Okay. Now the next one is the PI. So the particular integral yp is equal to, as you know, this divided by this. So sine hyperbolic x whole divided by d square minus d plus 1, and always it's the type number 1. So please refer the theory in the playlist. You will get a clear understanding, clear picture of how to identify the types. So always sine hyperbolic is a function which can be represented in terms of e raised to x. So sine hyperbolic x is e raised to x minus e raised to minus x by 2. So sine hyperbolic 1x is e raised to x minus e raised to minus x by 2 into d square minus d plus 1. And as I always keep on telling in the while doing problems and types, wherever in the numerator there is plus or minus sign, everything defines a different type. So please separate them. Okay, there is minus here, so we'll separate it. So right, so yp is equal to e raised to x by 2 into d square minus d plus 1 minus e raised to minus x by 2 into d square minus d plus 1. So both are type number 1. Here, what is type number 1? E raised to ax upon f of d. Okay, here what is the solution? Replace all the denominator d by a. Here see a e raised to 1x. Replace d by what? 1. Here e raised to minus 1x. Replace all d by minus 1. So this will be now, right here, yp is equal to e raised to x whole divided by 2 into c1 minus 1 plus 1. Fine. And here e raised to minus x divided by 2 into 1 plus 1 plus 1. Am I right? 1 minus 1, correct? And minus 1 square is plus 1 only, minus 1. This is plus 1. And minus d means minus 1 minus plus 1. Okay. So that implies the particular integral yp will be e raised to x by 2, correct? Because 1 and 1 cancels and 2 into 1 is 2, and this minus e raised to minus x divided by 1 plus 1, 2, 3, 3 to the 6. That's all. Therefore, the solution is, we can write CF plus PI. So y is equal to C1 cos of root 3 by 2x plus C2 sine of root 3 by 2x whole into e raised to 1 by 2x x, okay, and plus e raised to x by 2 minus e raised to minus x by 6. That's all. So that's the solution for this question. Okay. Fine. I hope you clearly understood this problem. Sine hyperbolic, they might also give sine hyperbolic 2x also. So when we give sine hyperbolic 2x, it will be e to 2x minus e to minus 2x by 2. So it is d by 2 and minus 2. Okay, that's the solution. It's for 7 marks. Fine. So please practice such questions to get the solutions right. Okay. So now let's move on to question number 7c. So question number 7c is solve d square plus 5d minus 6 into y equals sine of 4x into sin x. Okay. So again we write first the auxiliary equation d as m square minus 5m square plus 5m minus 6 is equal to 0, and find the roots here. So I'll use the calculator here again. So we have equation 3, 1 equals 5 equals minus 6 equals, so you get the roots as 1 and minus 6. M is equal to 1 comma minus 6 are the roots. A very simple question. Now for the roots 1 and minus 6, the CF will be, these are also both real and different roots. So C1 e raised to x plus C2 e raised to minus 6x. Okay. Please underline, always keep on repeating to get the required marks. Next, yp is equal to sine 4x into sin x divided by d square plus 5d minus 6. Now we discussed type 1 is e raised to x upon f of d replaced d by, type 2 was sin x or cos x upon f of d replaced d square minus c square. But again, while showing you the theory, I discussed a very important thing. It should be plain sine or cos. Sine into sine or cos into sine or cos into cos not allowed. It should be plain sine or cos only, then only you can apply. This is not type 2. Remember, this is not type 2. If it was sine 4x plus sine, then separate and type 2. Sine into is there, sine 4x into sine. Multiplication not allowed in mathematics. So sine into sine we formula you have to apply now. So you have to memorize the 3 formulas always. Listen to me carefully what I am telling. Instead of sine 4 sine, they can use sine cos or cos cos. There are 3 formulas. Cos A into cos B is half cos A plus B plus cos A minus B. Sin A into cos B is half sin A plus B plus sin A minus B. And sin A into sin B is half cos A minus B minus cos A plus B. Okay. So that is right here. So that will be half, what did I say? Half sin A into sin B is half cos A minus B, 4x minus x is cos 3x minus cos A plus B minus cos of 5x whole divided by d square plus 5d minus 6. I repeat, sin A into sin B is half cos A minus B minus cos A plus B. Now since there is minus sign, separate it, so yp becomes 1 by 2 cos of 3x whole divided by d square plus 5d minus 6 minus 1 by 2 cos 5x by d square minus 5d plus 5d minus 6. Now obviously this is type number 2. What is type number 2? Cos ax or sin x upon f of d. In type number 2 we don't touch the d's, only replace d square by minus a square. Here is 3 and here is 5. Perfect. That means replace here d square by minus 9 and here d square by minus 25, 5 square. Fine. Okay. Now this will be, that is yp is equal to 1 by 2 cos 3x divided by, see I am telling you what, replace only d square, don't touch the d's. Okay. D square by minus 9, so minus 9 plus 5d minus 6. Fine. Minus 9 plus 5d minus 6, and this will be minus 1 by 2. Okay. 1 by 2. This will be cos of 5x divided by minus 25 plus 5d minus 6. Fine. Now the in type 2 denominator needs to be discrete term, if not then rationalize. So again this will be yp is equal to 1 by 2 cos of 3x divided by, take always positive terms first, phi d minus 15, right? Phi d minus 9 minus 6 is 15 minus 1 by 2 cos phi x divided by phi d minus 25 minus 6 is 31. Okay. So this will be again now yp is equal to 1 by 2. See, the denominator there should be a d square term. If not, there is no d square term, then we need to rationalize. Fine. So this will be again cos 3x divided by phi d minus 15. What's the rationalizing factor of phi d minus 15? It's phi d plus 15 upon again phi d plus 15 minus 1 by 2 into, again this will be cos of phi x into upon phi d minus 31 into, again rationalizing factor is phi d plus 31 upon phi d plus 31. So let's see what happens here now. Okay, the question looks simple, but it's the values are becoming too big here now. So now, okay, let's see what happens. As we need to get a solution here. So now this will be 1 by 2. See, phi d cos of 3x plus 15 into, open the bracket, 15 into cos of 3x whole divided by, see, we need to rationalize, means a plus b, a minus b. This will be a square minus b square. So I will better do this with calculator here. Now this will be phi d square, right? So 25 d square minus 15 square. Okay. Fine. Again minus 1 by 2 into phi d cos of phi x plus 31 cos of phi x divided by again 25 d square minus 31 square. Okay. So this will be now 1 by 2. See, into d means what? Differentiate. Into d means differentiate. Fine. Getting it? So into d means differentiate. So into d cos 3x means differentiate cos 3x is minus 3 sin 3x. So see here carefully, phi d cos 3x, right? So d into cos 3x is differentiation of cos 3x is minus 3 sin 3x. Phi into minus 3 minus 15. So 1 by 2 minus 15. It will be sin 3x, done, because solving a differential equation means removing all the d's, plus 15 cos 3x as it is whole divided by, this will be 25 d square minus 15 square will be 10 into 15, better use a calculator, 225. Okay, 225 and minus 1 by 2 again. See, again 5d cos 3x, 5d cos phi x, sorry, 5d, this is cos phi x. Into d means again differentiation. Differentiation cos phi is minus 5 sin phi x. 5 is 25 minus 25 sin phi x, and this is how much? Open a bracket, 31, right? Okay, this will be 31 cos phi x. 31 cos of phi x whole divided by 25 d square, and what is 31 square? 31 square will be 961 minus 961. Okay, done. Now again for this replace d square by, we replace d square minus 9 and minus 25. So replace d square by minus 9 and here d square by minus 25. So we'll get a solution here now, that is equal to 1 by 2 minus 15 sin 3x plus 15 cos 3x whole divided by, so I will do it in calculator only. Okay, 25, I will take in bracket 25 into, so it's 25 d square is minus 9, right? Okay, 25 into minus 9 is equal to minus 225, minus 225 is equal to minus 450, minus 450 minus 1 by 2 again minus 25 sin phi x plus 31 cos phi x whole divided by 25 into again minus 25. So 25 into minus 25 equals to minus 961 is equal to 1586 minus 1586. So this is the solution. If you want to simplify or keep it as it is. This is YP. Okay. If you want, you can simplify it. 15 by 15 divided by 450 is equal to, you can write this as 1 by 2 into, see 15 by 15 divided by, I can reduce it to 450 is equal to 1 by 30, minus 1 become plus, so sin 3x by 30, again minus cos 3x by same thing 30, again minus 1 by 2 into, let's see if this possible, 25 divided by 1586 is equal to, okay, same only, again minus plus 25 by 1586 sine 56 plus and minus. Let's see if this reduces. 31 divided by 1586 is equal to same as it is. Okay, minus 31 by 1586 cos of phi x. If you want, you can multiply inside or leave it as it is. Okay, so the solution is y is equal to Cf plus Pi. So the Cf I got C1 e raised to x plus C2 e raised to minus 6x plus 1 by 2 into bracket sine 3x by 30 minus cos of 3x by 30 minus 25 sine phi x by 1586, again minus into minus become plus 31 by 1586 into, it is cos of phi x. That's all. So that's the solution for it. Okay, so usually they won't give problems like this, but since it is mentioned in the model question paper, I solved it for it completely. Okay, the things will be easy only here. Seeing the result and seeing this, don't take tension. So please, I think this won't be asked. So please, you can solve the other questions from the playlist which I have given. Those are very important. Okay, fine. So we are done with this solution of question number 7C. Now let's move to question number 8A. Okay, the question number 8A, it is or question number 8 is solve d square plus 1 into y equals cos x by variation of parameter. I didn't give a short form. Okay, so variation of parameters. So what is the d square plus 1 into y is equal to cos x. Fine. Again, so the method of variation parameter is, we first find the roots here. It is m square is equal to minus 1, that implies m is equal to plus or minus I. From this we get dCF. The CF will be here C1 cos x plus C2 sin of x. Okay. Now the method of variation of parameter says, from the CF only we assume the solution as to be y is equal to ay1 plus by2. Here y1 is cos x and y2 is sin x. Fine. It means now y1 is cos x and y2. We find Wronskian, that is w. W is equal to y1 y2 dash minus y2 y1 dash, that is cos x into differentiation of sin x is again cos x minus sin x into again differentiation cos x is minus sin x. So it is sin square x plus cos square x. So w will be equal to cos square x plus sin square x, that is 1. W is very important here, is equal to 1. So underline w. Okay, so the value of Wronskian is 1. Okay, so we found w. Now the formula to find, we need to find a and b, and putting the a and b we get the entire solution. So a is minus always integration of phi of x into y2 divided by w. Fine. Now here in the question of phi of x is this part, that is cos x upon w dx, constant I'll add later. So a is equal to minus, what is phi of x? Cos x, and what is y2? y2 is sin x upon 1 dx. I think a simple integration. So what I can do here is, see, wherever cos and sin is there, we can make it solid, because sin 2x is 2 sin x into cos x. Okay, so I can write this as multiply by 2 divided by 2. So a will be equal to minus, what I'll simply do, I'll multiply by 2, okay, 2 sin x into cos x and divide by 2 dx. Fine. So this will be now a is equal to minus 1 by 2 integration of sin 2x dx, and that implies a is equal to, see, integration of sin ax is minus cos ax by a. See, simple integration of sin x is minus cos x, but the integration of sin ax is minus cos ax by a. Remember it. So integration of sin of 2x will be minus cos 2x by 2. So here minus and minus become plus, so it becomes cos 2x divided by 2 to the 4, plus I take the constant k1. So now I found a1 here. Okay, getting now? So integration sin 2x is minus cos 2x by 2. So minus minus, there is minus sign here. So minus must become plus cos 2x by 2 to the 4. Similarly, now b is equal to integration of phi of x into y1 divided by w dx, and that will be again b is equal to integration. What is phi of x? Cos x. And what is y1? y1 is again, it's cos x dx upon 1. Okay, so see, phi of x is what? Cos x, and y1 is cos x. So we get this as b is equal to cos square x dx. Now how do we integrate cos square x? See, we have the formula. We try to make it standard form. So the formula is b is equal to, we can write cos square x is 1 plus cos 2x by 2. So 1 by 2 integration of 1 plus cos 2x dx, and that will be b is equal to 1 by 2 into integration of 1 is x and integration of cos 2x. So integration of cos ax is sin ax by a. Fine. So integration of cos 2x will be sin 2x by 2, plus I will take a constant, say k2. Okay, so I found a and b both. Therefore the solution will be y is equal to, just simply put here, that's enough. So a, what is a? It is cos 2x by 4 plus k1 whole into cos x plus b into y2. What is b? I will take it inside. So 1 x by 2, it is, I take this inside, x by 2 plus sin 2x by 4 plus k2, and that's enough. That's the solution. Okay. So the solution for this d² plus 1 into y is equal to cos x is here. Y is equal to cos 2x by 4 plus k1 into cos x, and my b was b into y2, x by 2 plus, I took it inside, plus sin 2x by 4 into, I forgot one thing, into sin x. That's the solution. That's it. Okay. So now let's move on to the next one, that is question number 8a, 8b. Fine. So the question number 8b is, solve x square d square y by dx square minus 3x dy by dx plus 5y is equal to x square cos log x. X square cos log x. I think there is a slight misprint in the model question paper. It should be x square d square by dx square minus 3x divided by dx plus 5y. Okay, so let's check it with the roots. Now this is clearly Cauchy's differential equation. Okay. So why Cauchy's? Because Cauchy's is x square y double dash plus x into y dash and so on. So simple x square d square by dx square x dy by dx is all Cauchy's. So in Cauchy's what we do? We put log of x is equal to t, that implies x is equal to e raised to t. Fine. This we take RHS. Now here in Cauchy's x square d square by dx square means d into d minus 1 into y minus 3 into x dy by dx means dy. Okay. So the theory I mentioned, as I repeat, I have given in the playlist. So I have mentioned the theory first, then the problem. So please do refer the playlist in the courses for more idea about how it works. So but simply remember here, in Cauchy's x square y double dash or x square d square by dx means d minus 1. See, x cube is d minus 2, x square means d minus 1 into y, and x means it is simply dy plus 5y is equal to, so what I told, when I put log x is equal to t and x is equal to e raised to t by the property of logarithm, that we use on the right side. Okay, it is, what is that, e raised to, what is the right side, e raised to 2t into cos of t log x is t. This is what you have here. So simplify this here now. So this will be d square minus d, I will take all y outside, minus 3d plus 5 whole into y equals e raised to 2t cos of t. That will be d square minus 4d plus 5 into y is equal to e raised to 2t into cos t. So first we find a CF here. So m square minus 4m plus 5 equals to 0. So let's find a root here now. First check is correct or not. So d square d minus, okay, perfect. So again we go to mode, equation, and polynomial second order, tier 3, 1 equals to minus 4 equals to 5 equals to, so it's 2 plus or minus I. So it implies m is equal to 2 plus or minus I. So now be careful here. See the rights, we have the habit of taking right side x, but here in legend or Cauchy's, the right side we take it as x, everything, sorry, in terms of t. So the variables are in not x, it's t. Therefore the CF here will be nothing but, see, for m is equal to 2 plus or minus I, we usually write c1 cos 2 cos x plus c2 sin x into e raised to x, but here the variable is t. So c1 cos of t plus c2 sin of t whole into e raised to 2t is the CF. So okay, so let's underline the CF here now. Fine. Now let's move to the particular integral. So here yp is equal to e raised to 2t into cos t divided by this is d square minus 4d plus 5, and here I have a little doubt because I don't know exactly. Please check your syllabuses. Okay, because there are actually as discussed in syllabus, there are 3 types, type 1, type 2, type 3, e raised to x, sin x and polynomial. This is type number 4 actually. Please check your syllabus if this there or not. And yeah, I saw it because since given model question paper. See, type 4 is nothing but e raised to x into something. Here e raised to x into sin. Plain e raised to x means type 1, replace d by. Plain sin or cos means type 2, and plain algebra means polynomial x square x cube means type 3. So when something multiplied e into something means type number 4. In type number 4 we replace d by d plus a. Which a? See this a. Right here, I'll mention here. See this a. We use this a. Which a? This a. See. 2t. Correct. So we use this and take it outside. So replace d by d plus 2. So that means when I make use of this 2, I throw it or I take it outside into, this will be cos t divided by, replace all the d's. Each and every d has to be replaced now. So d plus 2 the whole square minus 4 into d plus 2 plus 5. Okay. So this will be now e raised to 2t into cos t by, see, simplified, replace all the d's. See, all the d's are replaced. D plus 2 the whole square minus 4 d plus 2 plus 5. It is d square plus 4d plus 4 minus 4d minus 8 minus 4d open bracket minus 8 plus 5. So this will be now e raised to 2t into cos of phi t divided by cos of t, right? Okay, cos of t divided by cos t divided by d square. See here 4d cancels, and what remains? D square, and here it will be 4 minus 8 is minus 4, 5 minus 4 is 1, d square plus 1. Okay, correct now. So see, minus 8 plus 5 is minus 3, 4 minus 3 is 1. Now this is what type? See, when I replace d by d plus 2, this 2, the work is done. Inside this type is what? This is type 2, sin or cos. So where what to do type 2? Replace d square by minus a square. Now a is this one here, 1. Getting it? So here we replace d square by minus 1. So to do that, that implies yp is equal to e raised to 2t. So when I replace d square minus 1, alright, cos t by minus 1, in place of d square put minus 1, it becomes 0. Now in type what I do, if the denominator is 0, multiply the numerator by x, and here in this case the variable is t, multiply by t and differentiate the denominator. Differentiation of d square is what? 2d. This will be again now, right, to yp is equal to nothing but again, see, upon d means integration. So e raised to 2t pre-multiplied into t pre-multiplied. So 1 by 2 outside. Upon d means what? Integration. So integration of this cos t. Okay, integration of cos t. Why? Because into d means differentiation, upon d means integration. Now this will be e raised to 2t into t. Integration of cos t is plain, sin t upon 2. Now this is the particular integral which I have. So the solution is y is equal to c plus pi. So y will be equal to, what is c here? We found c1 cos t plus c2 sin t into e raised to 2t plus this will be e raised to 2t into t sin t by 2. So that's the answer, but finally since the question is given in terms of x, so the final solution needs to be in terms of x. So replace them appropriately. See, t is what? We'll take log x. Okay, everything placed in terms of x. So this will be c1 cos of log x plus c2 sin of log x whole into, see, x is e raised to t, e raised to 2t. E raised to t is what? X square. X is e raised to t, so x square is e raised to t. So in place of e raised to t, write x square. Similarly here also x square into log of x. X square into what? Log of x into sin log x, sin of log x divided by 2. That's all. This is the solution. So please verify your syllabus if whether you have type 4 or not, or it may be a misprint in the model question paper. Okay, so please verify it. So done. So we are done with the module 4. 7 A, B, C, then okay, or A is 8 A, B, C, A, B. Next is C is construct the governing equation of free damped motion of a mass, theoretical question. So I solve it here now. Now the final module is module 5, the student's favorite module, that is linear algebra. And please, one thing, be careful, many students make the mistake. Since it's very easy, they try to attempt the first in the examination. Please don't do that. I will not give an explanation, but please, based upon my experience, please listen to me. Please don't do that. Start from module 1, then 2, then you can go with module 5, so on, okay? So the first is find the rank of the matrix. Say I solved, in my previous videos, I solved numerous problems on rank, okay, which will be very helpful for you to understand the principle here. Well, I'll solve this also, so please do that. And also a reminder that once you are finished with the question, your exams, please do share your question paper on my WhatsApp number. Okay, it will be very beneficial for the future students. Fine, don't forget it. Now the question number 9th A. Question 9th A. Find rank of A is equal to 2, 3, minus 1, 1 minus 1 minus 2 minus 4, 3 1 3 minus 2, 6 3 0 7. So I need to find the rank of this matrix. So while taking down the question, please be careful. If you miss any numeric value or sign, then gone. Your whole efforts will go to waste, and plus the time. Time is precious in exams. Fine. So again reevaluate it. So 2 3 minus 1 minus 1, 1 minus 1 minus 2 minus 4, 3 1 3 minus 2, and lastly 6 3 0 7. Very important problem. They can repeat the same in the examination. So let's solve this now. So first, as you know, some authors, they while reducing the echelon form or row transformation, they advise the first element to be 1 if possible. So it's not required, but here since 1 is there, I'll just shift the rows. I will shift this row here. See, there is 1 here. I'll shift this row here and this row here according to row transformation. Okay, it won't change the matrix. So I'll rewrite this as A is equal to, what's that? 1 minus 1 minus 2 minus 4. Then this as it is 2 3 minus 1 minus 1. Then 3 1 3 and minus 2, 6 3 0 7. If you have followed my videos, I hope you remember the case of husband and wife. The first column, first person, first husband, 3 wives. All these 3 wives will go to the first husband. Then the second column, second person, 3, 2 wives. Then third person, 3. Okay, third column, third person. Then last is the bachelor. So for making use of this one, I need to make this, this and this all 0. Below the one, first column, first element, all should be 0. That's the concept of row transformation, reducing to echelon form. So first I need to make this 6 0 making use of 1. So how can I make 6 0 making use of 1? Very simple, 6 minus 6 0. So multiply the first row by 6. So I am writing this here so that you don't go wrong anywhere. You get a full marks. When I write like this, no. See, 6 into 1, 6 minus 6, 6 2s are 12 and 6 4s are 24. Okay, things become easy. So here what is the operation? R4 minus 6 R1. Fine. So this will be equal to now, what's that? See, when I multiply the row remains as it is, minus 1, minus 2, minus 4 as it is. Now see, 2, 3 go step by step, minus 1, minus 1 as it is. Then 3, 1, 3 and minus 2 as it is. Now 6 minus this 6. Getting it? I write for you. 6 operate on this. What chosen? Okay. 6 minus 6. I have to make this 0, right? 6 minus 6 is 0. Now see, 3, be careful here. 3 minus of operation is minus. So 3 minus or minus plus 6 is 9. 0 minus or minus plus 12 is plus 12. 7, see here carefully. 6 into 4, 24, right? Okay. 7 minus of minus plus 24 is 31. Done. This is what we get here. Okay. Now the next one. We need to make this, what is that? 3 0 making use of 1. Again what I do? How can I make 3 0 making use of 1? 3 minus 3 0. So multiply the first row by 3. 3 1s are 3. 3 minus 3 minus 6 and 3 4s are 12. So R3 minus 3 R1 is the operation. So this will be now again 1 minus 1 minus 2 minus 4 as it is. Fine. Then this 2, 3 minus 1 as it is. 3 minus 3, 3 minus 3, 0. And 1 minus 1 minus plus 3, 4. 3 minus plus 6, 9. Getting it? Then see minus 12, minus of minus, my operation is minus 3 or no. So minus 2, correct? Minus of minus plus 12. So 12 minus 2 is 10. And this will be as it is 0, 9, 12 and 31. Fine. Now we need to make this 2 0 making use of 1. So again 2 minus 2 0. So very simple thing. So multiply by 2. 2 1s are 2 minus 2 minus 4 minus 8. So R2 minus 2 R1, and this will become now 1 minus 1 minus 2 minus 4 as it is. 2 minus 2 0. 3, see again 3 minus 1 minus plus 2 is 5, be careful here. Then we have minus 1 minus plus 4. 4 minus 1 is 3, and minus 1 plus 8 minus 1 is 7. Okay, and this is 0, 4, 9, 10, 0, 9, 12, 31 as it is. Done. So below this one I made all 0. Now second, making use of this 5, I need to make this 9, 0. So I'll use numbers only here, okay? It will be easy for you. So making use of this 5, I have to make 9 and 4, 0. First column first person, second column second husband. Making use of 5 and to make 4 and 9, 0, below it 0. So first I'll make 9, 0 making use of 5. So how to make it 0? What's the LCM? LCM is 9 5s are 45. So what I'll do? I'll divide this by 5 and I'll divide this by 9. So 9 5s are 45, 9 3s are 27, 9 7s are 63, and here 0, 5 9s are 45, 5 12s are it's 60, and 5 31s are 155, correct? 5 on the 5, perfect. So 5 are 4 minus 9 are 2. Okay, so this will be now, I write here, this will be now again 1 minus 1 minus 2 minus 4 as it is, 0 5 3 7 as it is, 0 4 9 10 as it is. Now 0, 45 minus this 45, 0. Then we'll use calculator, so better not make any mistakes here, don't do mentally, okay? Otherwise you'll go mental. Make use of the calculator here. So we are on calculate, okay? So see, where were we? Yeah, it was 0, okay. 45 minus 45, 0. 60 minus 27, 60 minus 27 is equal to 33. And lastly 155 minus 63, 92. Okay, done. Okay, now next one is we need to make this 4 0 making use of 5, correct? Now this 5 is there, but we need to make, see, making use of 5 I made already this 0. Now making use of 5 I need to make 4 0, so LCM is 20. So into 5 into 4. So 0, 5 4s are 20, 5 9s are 45, 5 10s are 50, 0 4 5s are 20, 4 3s are 12, 4 7s are 28. So this is 5 R3 minus 4 R2, and this will be again 1 minus 1 minus 2 minus 4, 0 5 3 7 0. See, 20 minus 20 is 0. Again 45 minus 12, 33, and lastly 50 minus 28, 50 minus 28, 22. Okay, and lastly we have this 0 0. Okay, now see, okay, so this will be now again 33 and 92. Fine, so done. So below this 0, now below this 33 I have to make it 0. So very simple, I will do R4 minus R3. So that yields A is equal to 1 minus 1 minus 2 minus 4, 0 5 3 7, 0 0 33 22, 0 0 33 minus 33 is how much? 0, and 92 minus 22 is 70. That's the, so apart from this I cannot do anything else. So 1 2 3 4 rows, all, none of the whole row is 0, therefore rank of A is equal to how much? 4. That's the solution. Actually the same question is repeated in the one textbook, but you know the rank is actually here 3. There is, I think there is a slight misprint here. This has to be minus 7. If this, because in the question they given it as, I taken as in the question 6307. In the textbook the same question is there. This has been repeated in the previous examination, but actually the question is minus 10. So there is a typography error in the thing, I think in the question paper. So but since the same question is given that 6307, I solved it, so I got a rank as 4. If you take it minus 7, the rank will become 3, because it will be 33 and this is 22. So they both cancels and the whole row becomes 0. So rank will be 3. But in this case, as given in the model question paper, the rank is nothing but 4. That's it. Okay. Fine. That's about the ranks. So I request you to solve more questions on rank from my channel, playlist and courses. The next thing is question 9b, test for consistency of the following system. This problem I have already solved, so you can find the link in the description below. Fine. So next one is our 10th A. It is solve the following system by Gauss-Seidel method. Solve by Gauss-Seidel. A very simple method. So it says 10x plus y plus z is equal to 12. Then x plus 10y plus z is again 12. Then x plus y plus 10z is equal to 12. Gauss-Seidel method. So they are not given any initial values here. So if they don't give the initial values, they take x is 0, y is 0, z is 0. Okay. But first you need to check if I can apply Gauss-Seidel or not. So the condition is this should be greater than this. So 10 is greater than 1 plus 1. See, along the diagonal, 10 is greater than 1 plus 1. Okay. Again 10 greater than 1 plus 1. So again see, in the previous model question paper I uploaded, that is 1BMATC101, I also solved a question on Gauss-Seidel. Please refer that. See, I had done my part by providing the guidance and solution to all the model question papers I requested, in spite of my health condition. But now it's your responsibility to practice regularly, revise the videos and stay focused. See, even 1 week, I think 1 week is not there. I think 3 to 4 days, remember, that is enough. See, these days, if you have the correct resources, no, these 3-4 days are also enough to score 80 to 90% of marks, only if you utilize the time properly. Okay, so now coming back here. So see, 10x is equal to 10x plus y plus z is equal to 12. So we make equations for Gauss-Seidel. See, 10x plus y plus z is 12. So x will be equal to how much? 1 by 10, 12 minus y minus z. Okay, these equations are useful for iterations. Then from here, x plus 10y plus z is equal to 12. So y is equal to 1 by 10, 12 minus x minus z. And finally, z is equal to 1 by 10, 12 minus x minus y. So these equations are required for iterations. With these equations only, I go the iterations. And initially, I will take let x is equal to 0, y is equal to 0 and z is equal to 0. Okay. So we need calculator for this. So the first iteration is, see, initially we are taking 0, 0, 0. If they give the in the question, you take it. But here we take 0, 0, 0. But they are, because they are not given anything. Fine. Now since I will put here, so x is equal to 1 by 10. What is y? 0. What is that? 0. So 12 by 10 is nothing but how much? So you are making use of calculator here. Okay. So okay, 12 by 10 is 1.2. Fine. Fine. So next is your what is y? So y is equal to now again 1 by 10, 12 minus. See, this is initially x was 0. Now x is 1.2. This will become new x to the next iteration and it keeps on follows. That's all, as simple as that. So very simple method. So new x is now, see, 12 minus x is 1.2 minus 0. So that will be, it is 12 minus 1.2 is equal to divided by 10 is equal to, we are getting 1.08. Fine. The next iteration, z is equal to again 1 by 10, again 12 minus new x is 1.2, new y is 1.08. Fine. So this will be again 12 minus 1.2 minus 1.08 is equal to, divided by 10 is equal to, it's coming 0.972. 0.972. Fine. So now the second iteration is again same thing, second iteration. So in second iteration, again x is equal to 1 by 10, see, 12 minus y minus z, 12 minus, what is new y? 1.08. What is new z? 0.972. 0.972. So that will be 12 minus 1.08 minus 0.972. It's okay. 12 minus 1.08 minus 0.972 is equal to divided by 10 is equal to, it is coming around 0.9948. 9948. Take all the simplest, okay, minimum 4 to 5. Then similarly y is equal to again 1 by 10, 12 minus x minus z. So 12 minus new x is 0.9948 minus z was 0.972. 0.972, right? So that will be now 12 minus 0.9948 minus 0.972 will be divided by 10 equals to, so this is 1.00003332. Similarly z is equal to again 1 by 10, 12 minus x minus y, new x is 0.9948 and new y is 1.00332. So that will be now 12 minus 0.9948 minus 1.032 divided by 10 is equal to 1.000018. Okay, 1.0018. So it's my request to take all the minimum 5 decimal places, otherwise they won't give us. Then the third iteration, third one is x is equal to 1 by 10. Again, see 12 minus y minus z. So 12 minus, what is new y? 1.002 minus z is 0.00018. So that will be equal to now 12 minus 1.00332 is equal to divided by 10 is equal to 0.99965. Okay. Next, y is equal to 1 by 10 again, 12 minus x minus z. So 12 minus new x is 0.99965 minus z. What is z we got? 1.00018. Fine. Correct now. So y is equal to 12 minus x minus, okay, new z. So this will be again now 12 minus 0.99965 minus 1.00018. Yeah, right, is equal to divided by 10 is equal to 1.4017. One more I'll do. Okay, z is equal to now again 1 by 10, 12 minus x minus y. New x is 0.99965 minus 1.4017. That is equal to now 12 minus 0.99965. So it is divided by 10. It is 1.4033. So I think I can stop here, but the problem, no, it is asked for around, let me check it. Yes, 6 marks. It's I think enough. If you want to do, you can do one more iteration here. I'll tell you where to stop. See you again fourth iteration if you do. So x is equal to minimum 4 is required. Okay. Again 12 minus y minus z. So new y is 1.17 minus 1.23433. That is equal to 12 minus 1.123417 minus 7 is equal to divided by 10. So it's 0.12345. Okay. Then again lastly y is equal to 1 by 10, 12 minus x minus z. So 12 minus x is 5 minus new z is 1.123433. So 12 minus answer minus 1.123433 is equal to divided by 10 is equal to, it's approximating to 0.123 2, 3, 4, 5. Same thing. Lastly, z is equal to 1 by 10. It is 12 minus x minus y. So 12 minus x is 0. Minus y is again. So this will be now 12 minus 0. Minus is equal to divided by 10 is equal to 1.2. That's all. So I can stop here. So where to stop? See, the values will be similar here. See the x value here 0. Approximately similar, y similar. So, or the best thing to stop is, see, minimum 4 iterations are required. Okay, because the question is also 67 marks. So what you can do simply, you verify the answer here. See, mode, go to equation, then it is 1, 2, 3, ABCD, right? So number 2. So put all the values here. See, we have 10 is equal to 1 equal to 1 equal to 12 equal to 1 equal to 10 equal to 1 equals to 12 equals to 1 equals to 1 equals to 10 equals to 12 is equal to. See, the answer is coming as x is 1, y is 1 and z is 1. So we are getting it right, 1, 1, 1 approximately. That's all. So stop it there. Okay. So the solution is x is equal to 1, y is equal to 1 and z is equal to 1. That's all. So this is how we get for Gauss-Seidel method. A very simple method to follow, but you need hands-on calculator. So the more you practice, the more you become perfect. Okay. Now the next problem here is question 10b. 10b. It is apply power method. Okay. It's also called as Rayleigh's power method to find eigenvalues and eigenvectors. Okay, let's solve this question here. So the question is given as, I'll take this as A is equal to minus 2, 2, 3, 2, 1, 6 and 3, 6, minus 2. This is the question. See, here they are not given the initial eigenvector. So we have to choose the initial eigenvector here. If they are not given, you can choose as 1, 0, 0, 1, 0, 1 or 1, 1, 1, so on. So better is that, see, if you are choosing some value, say 1, 0, 0, and if you are not getting similar values around 4 to 5 iteration, then the solution may converge to a lengthier iteration. So then you can approximate to 1, 1, 1. Okay. So what I'll do here, I'll choose x naught as equal to, let initial eigenvector x naught is equal to 1, 1, 1 transpose. So transpose means eigenvector is always a column vector. So when I remove the transpose, it will stand up. So now first what will do, A into x naught. Fine. So A into x naught, so minus 2, 2, 3, 2, 1, 6, 3, 6, minus 2. Fine. See, fine. So A into x naught will be now, what is x naught I have chosen? 1, 1, 1. So now there is a use of calculator here. Fine. See, in my previous videos, if you follow the playlist, I solved one more very important problem on eigenvalue, eigenvectors. Okay, there I have showed how to use the both fx 991 ES plus second edition and fx 991 CW. So as it's a new syllabus, so I think many students have this Casio 991 CW, so I'm using here today, this one. Fine. Now, first, always while using a calculator, you need to reset the memory. So you go to home, then you go to calculate, then settings, reset. Okay, initialize all. Yes, fine. Now we are doing the operation on matrices here, so go to matrix mode. Fine. Okay, so first when I press matrix, it asks for tools. Go to tools, then matrix A, rows is 3 and the columns are also 3. Okay, confirm. So you'll enter the matrix here, minus 2, execute 2, execute 3, execute 2, execute 1, execute 6, execute 3 execute 6 execute minus 2. Okay, verified. Minus 2 2 3 2 and 6 3 6 minus 2. Okay, fine. Then again go to tools. We need matrix B now. So what I am doing here, I am taking this as, right here for you, matrix A and this as matrix B. Okay, this is the eigenvector, initial vector, 1 1 transpose. When I remove the transpose, it stands like this. Fine. Now what happens here is that okay, this okay, I have to write a matrix set. So rows are 3 rows and column is 1 column. Fine. Confirm. So 1 execute 1 execute 1 execute. Yes. Now to multiply we need to go to catalog, matrix, then matrix A into catalog, matrix, then we have matrix B, right? Okay. So we have into catalog, matrix, mat B is here. Fine. Execute. So we get the values as 3 9 7. 3 9 and 7. Fine. Now the highest number here is 9. So always divide by that highest number. That gives the eigenvalue. So we are finding the highest eigenvalue, eigenvector here. The highest value is the eigenvalue. So if you divide by 9 here, so take it outside, divide by 9 here only. Okay, we get 0.333. I think 4 3s, 1 and 0.47. Now this becomes a new eigenvalue. Now this becomes a new eigenvalue and this is the new eigenvector x1. That's it. Okay. Now again what we need to do, A into x1 is equal to, so minus 2 2 3 2 1 6 3 6 minus 2 into the new value of eigenvector is 0.1 0.7. Now see, you need not, one simple trick I am showing you. As soon as I press execute, this value gets stored in where? Matrix answer. That means now each and every step you need to keep on multiplying. See, everything is stored here, so you need not enter anything else. So multiply A by mat answer. Again keep on repeating everything till the values match. Okay. So yeah, what I am doing now, simply nothing. Press AC, catalog, matrix, mat A into catalog, matrix, mat answer. That's all. Execute. Again 3 point, I am getting these values. So again I am getting it, I write here for you. So 3.46, 6.3 and 5.4. Now the highest number here is 6.3. Correct. So what I do, I divide by 6 point, that gives the eigenvalue. So we get 0.5785, 0.5785, 1 and 0.8596. Now this is my new eigenvalue lambda 2 and this is my new eigenvector x2. Okay. Now again A into x2 is equal to minus 2 2 3 2 1 6 3 6 minus 2 into 0.5785 1 0.8596. So I'll do directly here. So what I do now, again catalog, matrix A into again catalog, matrix answer. Execute. So you get 3.421, 7.315, 6.0175. So the highest value is 7.3158, 7.31. I write directly. So divide the whole thing by 7.315, 7.3158 is equal to, so 0.4676, 0.4676, 1 and 0.8225. Okay. So my new eigenvalue here and my new eigenvector. So lambda 3 and this is x3. This is x2 and this is x3. Fine. Now again A into x3 is equal to minus 2 2 3 2 1 6 3 6 minus 2 into 0.4676, that's the answer, 1 0.8225. Okay. So as you know the process now, this will be again AC, catalog, matrix, go to matrix A into catalog, matrix, go to mat answer, execute. So again I am getting the highest value as 6.8705. 6.8705. So divide by 6.8705 is equal to 0.5141, 0.5141, 1, 0.838. Okay, so this becomes my new eigenvalue lambda 3, lambda 4, and this is new eigenvector x4. Okay, now next step is again a into x4. So right here a into x4 is equal to minus 2 2 3 minus 2 2 3 2 1 6 3 6 2 into 0.5141 1 0.838. Again catalog matrix A into catalog matrix, go to mat answer, execute. So 7.0565 is highest number, 7.0565 divided by 7.0565. So 0.4939, 0.4939, 1, 0.8313. So it keep on repeating till the values match. So they are not matching that much approximately. Again I will take a into x5. Okay. Minus 2 2 3 2 1 6 3 6 2 into, this will be 0.49391, 0.8313. Again this is catalog matrix A into catalog matrix mat answer, execute. So again the highest number is 6.976. 6.976. I think it's nearing, divided by 6.976 is equal to 0.5025, 0.5025, 1, 0.8341. Okay. I think the values are nearing here. So I will do a last iteration. So a into x6 is equal to minus 2 2 3 2 1 6 3 6 2 into 0.5025, 1, 0.8341. So this will be again now catalog matrix A into catalog matrix, go down to get the answer. Okay, execute. So we are getting 7.0103. okay, it's nearing. So 7.0103 divided by 7.0103 is equal to 0.4988, 0.4988, then 1, 0.833. That's what I'm getting. I think we can stop here only, because see here the values are matching. See this approximately, this one, see they are same, like 6.976 approx. 0.5, 1, 0.8303. That's all. So stop it there. Therefore the eigenvalue, the highest eigen or eigenvalue is lambda is equal to 7.0103, and the highest eigenvector is x is equal to, we can write 0.4988, 1, 0.833. That's the answer. You can approximate to 0.5. Okay, if you wish, or keep it as it is. Or if you want to write in transpose, you can write it also as, this is also equal to 0.4988, 1, 0.833 transpose. That's all. So we have found the highest eigenvalue and the eigenvector for this question here. So see the initial eigenvector, no? In many books they choose one, initially see 1 0 0, 0 1 0 1, 0 0 1 or 1 1. So I have chosen 1 here because I think if you choose 1 0 0, it may go up to some 13-14 iterations. So find it's better to choose values as 1 0 1 or 1 1. Okay, that's all. So this is how we get the eigenvalue and the eigenvector for the matrix. So that is solution. but you need hands-on calculator to get the correct answer. So for that, again I request you to please go refer my one more video on eigenvalue eigenvector, that is I explain how to use in a complete detail way. It will be very beneficial for you. Okay, we are done with question 10b. The last one is 10c. Diagonalize the matrix, and for VTU syllabus you have only 2 by 2 matrix, that is A is equal to 4 1 2 3. I have solved this solution already in a very simplest or the most simplest way possible. Please go and refer the link in the description. So that's all. I think we are done with the model question paper as requested for 1BMATC101, and please do follow the Facebook, Instagram page and check out the important questions, practice those since the exam is nearing. And I have done my job already. Fine. I shown you all the, I done my maximum possible to guide you through the process. Now it's your responsibility to practice regularly, revise the videos and stay focused. As I tell you, this 3 to 4 days time is also enough for you when you have the proper resources to get more than 80-90% marks. So that's it. So stay confident, practice well, keep revising. See you in the next semester, that is second semester. And I want you and I request you to please send the question papers after the exams on my WhatsApp number. I shared it in the description. So please do that. So see you in the next semester. Till then, best of luck for exams. Bye.